Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson, which will be your first lesson on Geometrical Map Projection. Last time, you learned that map projection is a technique used by cartographers to transfer the information from a globe onto a flat surface. You learned that while this process can create useful maps, it also involves an element of distortion. Cartographers must choose whether it is most important to have accuracy of area, shape, distance, or direction for a specific map, and then sacrifice the accuracy of some or all of the other features. You learned that homolographic projections maintain accuracy of shape. Orthomorphic projections maintain accuracy of size, and azimuthal projections maintain accuracy of direction. Today, you are going to learn about a specific type of map projection called Cylindrical Map Projection. You will learn what it is, what its characteristics are, and what types of maps it is best suited for creating. Students, I wonder if you have ever seen a ball kept inside of a cylinder. A good example of this is a tennis ball inside its cylindrical packaging. This is a helpful metaphor for understanding how cylindrical map projection works. As you see here, the cylinder tangents the balls at both sides. From this image, can you think of how the cylindrical projection technique works? Try to explain the process in your own words. How can cartographers use a cylinder to transfer the information from the globe onto a flat plane?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, class. Cylindrical projections are any projection in which the meridians are mapped to equally spaced vertical lines, and the circles of latitude are mapped to horizontal lines. You can imagine the mapping of meridians to vertical lines by thinking about a cylinder wrapped around the Earth, projecting the information from the globe onto that cylinder, and then subsequently unfolding the cylinder. By doing this, cartographers can create a rectangular plane surface or a flat map. Was your answer similar to mine? If so, well done. Students, take a moment to think about cylindrical map projection. While this is a great method for creating maps, it is not without flaws. Which portions of the resulting maps do you think will be most accurate, and which parts will have the most distortion, and why?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you had no trouble answering this question. The most accurate portion of a map created by cylindrical projection lies along the equator. The distortions increase polewards from the equator. This is because the lines tangent the Earth during this type of projection at the equator and are thus truest to scale. Each type of map projection is most appropriate for depicting a specific part of the Earth's surface based on that type of projection's individual characteristics. Cylindrical projections are best suited for the projection of tropical regions, as these parts of the world lie on or around the equator. Students, let us discuss a few more characteristics of cylindrical projection. Parallels and meridians in such a projection are straight lines that intersect at right angles. All of the parallel lines are equal in length to the equator, and as we discussed, the lines tangent to the developable surface are true to scale. In a moment, you will see a list of sentences related to our lesson. Please decide whether each sentence is true or false. If it is false, correct the statement.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Were you able to determine which statements are true and which are false? Let us go through them together. The first statement is false. Cylindrical projections are actually best suited for the projection of tropical regions. This is because the deformities increase polewards. Therefore, the second statement is also false. Distortions increase polewards from the equator. The third statement is true. All parallels are equal in length to the equator. The final statement is false. Parallels and meridians in cylindrical map projections are actually straight lines that intersect at right angles. Well done, students. Now, if you ever want to create your own map projection of the tropical regions of the world, you will know which type of map projection to use. Since Ethiopia is situated very close to the equator, it would appear quite accurate on a map created using cylindrical projection. In today's lesson, you learned about cylindrical map projection. To perform this technique, cartographers would wrap a cylindrical developable surface around the globe, ensuring that the globe is tangent to the cylinder. Then, data from the globe would be captured onto the surface of the cylinder. The cylinder would then be removed, cut open, and flattened to create a rectangular plane surface. You learned that this method of projection is best suited for the projection of tropical regions because the lines tangent to the developable surface of the cylinder, which lie at the Earth's equator, are true to scale. This brings us to the end of our lesson for today. Next time, you will learn about another type of map projection, conic projection. You will learn what it is, what its characteristics are, and what type of map it best produces. Until next time, thank you, teacher. Thank you, students.